All right, guys, today we are cramming a whole bunch of trigonometry into one day. This is probably a couple weeks worth of information, and we're going to try and get through it in a day so we can get caught up with what everybody else is doing and give you just the way the schedule is going to fall the next couple of weeks. We're going to kind of hammer through this one just so that your test days fall on the right day and we have a little bit better schedule with reviews and things. So first thing that we're going to talk about is just a quick review of the Pythagorean Theorem. Now, when we're dealing with triangles these next couple of days, all of our triangles are going to be right triangles, meaning they're going to have a 90-degree angle. And that's going to be the case for the next probably week and a half. These are the only type of triangles that we're going to use, are right triangles. And a couple of things to remember about a right triangle. The side of the triangle across from the 90-degree angle, this side right here, C, we call the hypotenuse. So as I'm going to be using that word quite a bit, it's going to come out a lot. But the hypotenuse is the side that's across from the 90-degree angle. So you're going to want to remember that one. But back to the Pythagorean Theorem. This goes back to, I think, 8th grade is when this is first introduced to you. But it basically says that if you have a right triangle, here's the formula right here. If you have a right triangle, then a squared, if I take one of the sides of the triangle and square it, plus b squared and add it to the other side of the triangle, then those are going to add up to equal the hypotenuse squared. So a squared plus b squared equals c squared. There's not a lot of things that your parents are going to remember about high school math, but the Pythagorean theorem, a squared plus b squared equals c squared, they are going to remember because we use this one a lot. So let's look at an example of how we can use this. In a right triangle, a lot of times we don't know all the sides. So in this problem, it says the legs of a right triangle have lengths 10 and 24. What is the length of the hypotenuse? Well, first of all, I'm going to draw a picture because it bothers me not to know what I'm looking at. So I have a right triangle and it says, what is the length of the hypotenuse? So I know I'm looking for the hypotenuse. And it says I have a leg that is 10 long and another leg that is 24. That is an awful 24. A 10 long and one that is 24 long. What is the length of the hypotenuse? So I'm looking for this length here, and I'm going to use my Pythagorean theorem, my formula up here. A squared plus b squared equals c squared. So all I do is plug in these two sides for a and b. So 10 squared plus 24 squared equals x squared. Do not forget the squared. Don't put that they just equal x. You need to put that they equal x squared. And then we know, I don't know 24 squared, so that's why I grabbed the calculator. But I do know that 10 squared is 100, and 24 squared is 576. So those equal x squared. I can add these together, so 676 equals x squared. When I've taught this in the past, a lot of people want to tell me 676 is the answer, but you have to remember that that's equal to x squared. So I have to square root both sides. And when I take the square root of 676, I get 26 equals x. And remember, there's actually a positive and a minus 26, but when we're dealing with shapes, we ignore the minus. So x is just going to be the positive 26. So if this side is 10, this side is 24, then this length right here is going to be 26. Okay, so let's try one more. Find the value of x. So I've got two sides and I'm looking for the hypotenuse. I'm looking for c. So 8 squared, if I square this side, plus 15 squared is going to equal my hypotenuse, x squared, the side that's across from the 90. So 8 squared is 64. 15 squared is what? 15 times 10 is 150 plus another 75. So we're going to get 225-ish. Yeah, 225. So 225 equals x squared. 64 plus 225, we're going to get 289 equals x squared. And then I need to remember to get rid of the square root. So let's square root 289, and we're going to get 17 is equal to x. So that means this side is 17 long. So that's how we find the hypotenuse. Now, it doesn't always ask us to find the hypotenuse. In these examples, it tells us that the hypotenuse of a right triangle has length 12. So let's draw this picture. If I have a triangle here, and my hypotenuse is 12, one of the legs is 6. What is the length of the other? So I know this is 12, this is 6. I'm looking for the unknown leg. So when I plug these into my equation, I'm going to get x squared, the one I don't know, plus 6 squared equals 12 squared. The 12 now goes on this side of the equal sign. So x squared plus 36 equals 144. If I minus 36 from both sides, x squared is going to equal 108. And it wants our answer in simplest radical form. So when I square root my 108, remember when you put that in the calculator, I should probably pull my calculator up on screen to show you that. When I want the square root of 108, it wants me to simplify this. So 108 I know is 4 times what? 27. And I know the square root of 4, so that can go on the outside of the square root. So now I've got square root of 27. And 27 is going to break up into what? Whoops, that's not what I meant to do. Our 27 is going to break up into 3 times 9. And I know the square root of 9. It's 3, so I can also pull a 3 out. So now I have a 2 and a 3 on the outside and a 3 on the inside. So 2 times 3 is 6, square root 3. So this side right here is going to be 6 square root 3. If you have trouble simplifying radical form, come see me. I can help you out with that. All right, let's try these two. Again, I know the hypotenuse. I'm looking for one of the sides. So I have x squared plus 4 squared equals 7 squared. So x squared plus 16 equals 49. If I minus 16 from both sides, x squared is going to equal, 43, 33. So I need a square root 33. So x equals the square root of 33. And the only thing that goes into 33 is 11 and 3. And neither of those we know the square root of. So x is going to be square root 33, which I'm okay with that answer. You're going to be, obviously, square root of 5 is 25. Square root of 6 is 36. So you're a little bit closer to 6 on that length. All right, so x squared, and we have a 6 right here. So again, I know the c. This is my c squared. So I have x squared plus x squared equals 6 squared. Let's combine like terms. 1x squared plus another x squared is 2x squared equals 6 squared. So 2x squared equals 36. Divide by 2. X squared equals 18. Square root of 18. We're going to get x equals 18. We do what? 2 times 9. And I know the square root of 9. 18 breaks up into 2 times 9. Square root of 9 is 3, so I can move that to the outside, and I'm left with a 2 on the inside. So x is going to be 3 square root 2. All right, there's your review. That's what you've learned about trigonometry so far. We get to add some really fun stuff today. And I don't mean that sarcastically. I mean that I think this stuff is interesting. I think it's fun to work with. we're going to add what we... All right, guys, let's try this again. That last recording failed partway through, so we'll pick up where we left off. We're talking about trig ratios, and there's three important ones that we're going to discuss today: the sine, cosine, and tangent of different angles. So the way this breaks down is we're looking at the sine, cosine, and tangent of angle A, which is this angle right here. We're talking about this angle, this blue one here in the corner. Now, before I can answer what the sine, cosine, and tangent is, I need to look at this angle and compare it to my triangle. Across from my 90-degree angle, this is always my hypotenuse. And we're going to just use H to abbreviate. The side across from the 90 is always H, the hypotenuse. The side across from my angle is always called the opposite side. And we're going to abbreviate with the letter O. And I know I don't like to do that because it looks like a zero, but today we need to call that O for opposite. And then the side that is connected to A, that's not the hypotenuse, the other side that's connected to A, we call the adjacent side. And we're going to abbreviate that with an A. So the way sine, cosine, and tangent work is if I take the sine, and I'm going to abbreviate S-I-N-E, we're going to do sine of A, the sine of this angle, whatever degrees that angle is. It's really cool because that's equal to a ratio of the sides of the triangle. So the sine of the angle, of the degrees of the angle, is actually equal to two of these sides in a ratio. And the two sides that go with sine is we put the opposite side on top and the hypotenuse on the bottom. So the sine of this angle is equal to the opposite over hypotenuse. The cosine of angle A is equal to the adjacent side. Here's my angle A. This is my adjacent side over the hypotenuse. And the tangent of A is equal to the opposite side divided by the adjacent side. That ratio, O over A, opposite over adjacent. If you were to ask your parents about sine, cosine, tangent, or if you were to ask them about the phrase SOHCAHTOA, they're probably going to remember that. This is something that we have used a lot. You use this a lot in school. You use this a lot in math. You use this a lot in engineering, in science, in graphic design, in art design. This idea of the sides of a right angle triangle. And remember, these are only true of right triangles, but this is a really common used ratio. And so most teachers teach you to remember SOHCAHTOA. S-O-H, the SO part, stands for the sine is the opposite over hypotenuse. That's S-O-H. So is sine opposite hypotenuse. SOHCAHTOA, the ka part, the C-A-H, is to help you remember the cosine equals adjacent over hypotenuse, cosine adjacent hypotenuse. And the TOA is the tangent, is the O over the A. So SOHCAHTOA is just a little phrase, a little common term that mathematicians use to remind you of the order that these ratios come in. Okay? Now, here's what it looks like in the real world. So if I have a triangle, and I'm just going to give you a quick example, and then we'll do some ratios. If I have a triangle right here, here's my 90-degree angle, and let's say that this is 46 degrees, and across from it, I've got this side of my triangle that measures 5. Now, I don't know if this is actually true or not. I'm just making up these numbers, but let's say this is 5, and this side right here is 7. I can write out one of these ratios. I can say that the sine, and I'm using sine because 5 is the opposite and 7 is my hypotenuse. The sine of 46 degrees is equal to the opposite side, 5, over the hypotenuse, which is 7. So the sine of 46 is equal to 5 over 7. Okay. Well, let's write a few of these ratios out. I'm going to go kind of fast because this is a video. If you need me to slow down, you can hit pause. If you need me to go back and repeat something, you can hit rewind. So I'm going to go kind of fast just to make sure we get through all of this in a reasonable amount of time here to get this uploaded for you for the weekend. If I want to write the ratios for the sine of m, cosine of m, and tangent of m, we're talking about angle m, which is this angle right here. First thing I want to always do with my right triangles is recognize this is my hypotenuse. And then if I'm dealing with angle m, the opposite of angle m is over here. That's my 7, which makes the 24 my adjacent. The reason I want to do that first is if I'm looking at angle L, my hypotenuse is still going to be the 25, but my O and my H are going to actually change. So this isn't true all of the time. This is only true when I'm dealing with angle M. So if I want to know the sine of angle M, that's going to equal, remember sine, I put a little note up here, a little diagram on your notes to help you remember SOHCAHTOA, to help you remember where things go. Ignore the arrows. This doesn't mean that cosine goes up and adjacent goes down. The arrows just point to the word that represents that letter. So is sine of opposite and hypotenuse. So my sine is the opposite over hypotenuse, which in this case, my opposite is 7. My hypotenuse is 25. My cosine of m is going to be my adjacent side over my hypotenuse. And my adjacent is 24, and that goes over 25. The tangent of m, remember tangent is opposite over adjacent, which in this case is going to be 7 over 24. The opposite side 7 over the adjacent 24. Down here, I'm going to go through this example again. This is angle M that I'm interested in. 4 is my hypotenuse because it's across from the 90. 2 root 3 is my opposite because it's across from M, and 2 would be my adjacent. So the sine of M, again, I'm looking at the opposite over the hypotenuse. My opposite is 2 root 3, and my hypotenuse is 4. The computer won't like this answer because 2 over 4 simplifies to 1/2. So on top, I'm just left with square root 3 over 2. 2 over 4 simplifies to 1 over 2. I didn't write the 1 because I don't need to. I'm just multiplying. And the bottom changed to a 2. The cosine of m equals the adjacent over hypotenuse. My adjacent is 2, so that goes on top. The hypotenuse is 4, and hopefully you know that 2/4 reduces to 1/2. And then we have tangent of m, which is opposite over adjacent. My opposite, again, is 2 root 3. That's my opposite side. And my adjacent side, is this one right here, 2 root 3 over 2. If I get rid of the 2's, I'm left with root 3 is my tangent. All right. Now, as far as doing some math, I'm sure you've noticed that sine, cosine, and tangent button are on your calculators. If you don't have a calculator at home, you're going to want to use the website Desmos. It's a free graphing calculator online that you can use to help you with a lot of these problems. So when you're looking for the side of a triangle, say I have a right triangle. I know it's a right triangle because it tells me right here, look at this square. I'm a right triangle. I've got 2 sides, but one of them, I don't know what W is, but I do know one of my angles. And what's cool about this is if I know any angle, not the 90, of course, either of my other angles and a side, I can figure out the other sides. So step 1 is we're going to start with our given angle, this 54 degrees. That's my given angle. And I want to identify which side of the triangle I know and which side I need to find. So when I look at my triangle, here's 54. The 17 is the side that I know. That's my hypotenuse. So I know my hypotenuse. The part I don't know compared to 54, that's across from 54 degrees, which means this is my opposite. So I know the hypotenuse. I don't know the opposite. That makes this my adjacent, which I don't really care about in this problem because there's no information there for me. So I'm looking at H and O, the hypotenuse and the opposite. So what I want to do is find my trig ratio that matches h and o, which happens to be the sine function. It's not always going to be the sine function, guys. I'm using sine because I'm looking at the hypotenuse and the opposite. If I was looking at the adjacent and hypotenuse, I would use cosine. In this case, I'm going to use the sine function. So I'm going to substitute the parts of the trig into the trig function that's going to help me find my unknown value. So the sine of my angle, 54 degrees, the sine of 54 degrees is equal to the opposite side, w, over the hypotenuse, 17. And then from here, all I have to do is solve for the variable. I treat this just like railroad tracks. I've got sine of 54 equals w over 17. Be careful, sine of 54, that's just a number. Okay, we're not going to, sine of 54 is an actual number. So I don't want to change anything with that part, but I do want to get w by itself. So I multiply both sides by 17 to get rid of that divide by 17, which means that the sine of 54 multiplied by 17 is going to be equal to w. So now I need to know how to actually find this right here, sine of 54 times 17. To do that, all you do is go to your calculator. I'll try and clear that so your answer's not already there. Before you start trying to do the math, click on mode and just make sure that you're not in radian mode. You need to go down and make sure that this is set to degrees. Otherwise, you'll get the wrong answer. So I go back, and what I want to do is sine of 54 multiplied by 17. So on your calculator, you have a sine button right here, sine, and notice that it gives me a parenthesis, 54. Don't forget to close the parenthesis because the times 17 isn't inside the sine function. That 17 is not part of sine of 54. So I don't want to put it in the parentheses. So sine of 54 times 17, I hit enter, and I get 13.75. And depending on the question, it's going to ask you to round either 2 decimal places, or it might ask you to round to the nearest integer. I don't know, or the whole number. It just depends on the problem that you're doing. All right. So I know that W is about 13.75 would be W. Uh-oh, where'd our screen go? There we go. W is about 13.75. Okay, let's try a couple more examples. It would be a good idea for you to pause the video and try these on your own. If you can figure them out, great. If not, maybe go back and watch what we do again. But I'm looking first at my angle right here, 28 degrees. And I am interested in the 2 sides that it gives me. From my angle, the 1 is the opposite and the W is adjacent because this one's my hypotenuse. Sometimes hypotenuse is easiest to label first. Maybe I should have done that for you. But I know the W and the 1.0, which are my adjacent and opposite. So when I look at my little cheat sheet up here, sine is opposite hypotenuse, cosine is adjacent hypotenuse, tangent uses opposite and adjacent, which is what I have. So I'm going to take the tangent of 28 degrees of my angle is going to be equal to the opposite, which is 1, divided by the adjacent, which is W. Now, a lot of kids panicked today when they saw this W on the bottom. What's the opposite of dividing by W? You just times by W over here to make that go away. And then I times by W on this side, and that makes my W move over to here. So I've got W times tangent of 28 equals 1. Now I want to get W by itself. And right now it's being multiplied by tangent 28. So I'm going to do the opposite. I'm going to divide by the tangent of 28 on both sides. So W is equal to 1 divided by the tangent of 28 degrees, which is equal to, let's use our calculator. I'm going to click on the tangent button, which is right here. Actually, not yet. Sorry, I've got to do 1 divided by tangent of, what was my degrees? 28 degrees. So 1 divided by the tangent of 28. I hit enter, and my answer is 1.88. So that means that W is about 1.88, which is this side right here. And that makes sense. If this side is 1, this side being 1.88 is not unreasonable. The second one, I'm looking at 33 degrees, which is this angle here. Here's my hypotenuse because it's across from the 90. This angle over here is across from 33, so that's opposite, which makes this adjacent. So I know the hypotenuse, I know adjacent, which means I'm going to use cosine because they use adjacent and hypotenuse. So the cosine of 33 degrees is equal to the adjacent goes on top, so W goes on top, 4.5 goes on bottom. And then to solve, I'm just going to multiply both sides by 4.5. And that's going to equal W. So let's do cosine of 33 multiplied by 4.5. And again, I put a parenthesis after my cosine number there. Cosine of 33 degrees times 4.5 is 3.77. So W equals 3.77. So this side, again, I'm going to look and make sure that seems reasonable. If my hypotenuse is 4.5, it should be bigger than W, and it is. But 3.77 is not an unreasonable answer. So we can use sine, cosine, tangent to help us find the side. But what if I have a situation like this one where it gives me a right triangle? Again, I know this is 90 degrees. But it tells me two of the sides of the triangle, but I don't know either of these two angles. Well, I can still use sine, cosine, and tangent to find those angles. We're just going to use it a little bit different. In fact, up here on your notes where it says finding angles, why don't you put sine with a little -1 above it, cosine with a little -1, and tangent with a little -1. These are functions that we're going to use to find the angle, and they'll make sense in a minute. I just want you to have those written up there. So step 1, identify which angle you're looking for and how the sides that you know of the triangle relate to that angle. Well, in this problem, it just gives us a picture. We don't know which angle. So let's start with angle Y. Let's look at angle Y first, this angle right here. And I need to identify the sides that I'm looking for. So I'm looking at angle Y. And for angle Y, this is the hypotenuse because it's across from the 90. 41 is connected to Y, so that makes it the adjacent. And 100 is opposite the Y, so that makes it my opposite. So I have the adjacent and I have the opposite sides. So step 2 says to look for which trig function uses adjacent and opposite. And again, that's my tangent, SOHCAHTOA. TOA stands for tangent, that uses my opposite over adjacent. Okay. Now I just plug in the values to that trig function. So the tangent of angle Y, we don't know what that angle is, so that's going to be my variable. The tangent of this angle that I don't know is equal to the opposite side, 100, divided by the adjacent side, 41. Now, here's where we do something a little bit different, because if I were to tell you, if I had x squared equals 7, how would you get rid of the squared? You do the opposite of squaring, which is square rooting. And you would square root both sides. If I had x plus 5 equals 7, you would do the opposite of adding 5 by subtracting 5. We do the exact same thing with this problem. I do the opposite of tangent, which sounds kind of weird, but I'm going to do the opposite of tangent. I'm going to scroll down just a little bit to give me some room. So if I have the tangent y equals 100 over 41, the opposite of tangent is just tangent. We call this inverse tangent, tangent to the -1. So tangent to the -1 is the opposite of doing the tangent. So if I do that to the left and I take the tangent of -1 on the right, these go away because they cancel each other out. And all I'm left with is a y on this side, which is what I want. And on this side, I'm taking the inverse tangent of whatever's on that side, 100 divided by 41. So inverse tangent, that's just another button on your calculator. If you noticed that they're on the tangent button, right above it in blue letters is tangent to the -1. So instead of using tangent, I'm going to do second tangent. So I get tangent inverse, and I'm going to do 100 divided by 41. And that gives me my angle, 67.7 degrees. So y is equal to 67.7 degrees. So if I go up to my picture, that means that this angle right here is 67.7. Now I have options. If I wanted to find P, I could do the same thing I just did, or I know that angles add up to 180 in a triangle. Well, there's one of my angles. There's another one of my angles. So it would be really easy to figure out P without having to do all of this sine, cosine, tangent stuff. So let's try a few. I'm looking for angle X. And in this triangle, here's my hypotenuse. Across from X is the 8, and connected to the X is the 5. So that's my adjacent. Across is my opposite. So I'm looking for something that uses opposite and adjacent, which is tangent again. So I'm going to do the tangent of X equals the opposite side, 8, divided by the adjacent side, 5. And to get rid of tangent, I do inverse tangent to both sides. So inverse tangent of 8/5. So in my calculator, second tangent to get the inverse of 8/5. And it gives me 57.99, which is about, X is going to be about 58 degrees. You're not going to get very nice numbers on these, so be careful. The problems on the homework are going to tell you how to round it, but you are going to have to do some rounding one way or the other. Number 6 here is my angle X. This is my hypotenuse. Across from X is the opposite, and connected to X is the adjacent. So I'm looking at the adjacent side and the hypotenuse, which is cosine. Cosine uses adjacent and hypotenuse. So the cosine of X equals adjacent on top, 9 goes on top, 13 is my hypotenuse, that goes on the bottom. And to get rid of cosine so that X is by itself, I'm going to do inverse cosine to both sides. And that'll give me my X. So I'm going to do inverse cosine. Second cosine gives me the inverse. And I'm doing 9/13. So 9 divided by 13. Then I close those parentheses. And it tells me my angle is 46.1869. And let's say it wants us to round to the nearest whole number. So looking at my calculator, again, 46.18 just rounds to 46 degrees is about what my answer would be. Okay, so that's sine, cosine, tangent. Ask your parents about SOHCAHTOA. I bet they remember some of this stuff. Homework 25 is what you're going to be working on. It's due on Tuesday. If you have questions, come in Monday morning during lunch after school, or even Tuesday. I'm happy to help you out. But don't go all weekend without giving these a try. It's going to take a few to get the hang of it. But I think this is something, by the time we're done with all this, you'll have a pretty good handle on it. So good luck.